Alright, so today we're going to go ahead and go over the 4 problems that you should have done for homework yesterday. So, problem number 1, we have an object rolling off a desk at 3 meters per second, and it lands 0.4 seconds later. Now the first step to this problem and any other problem is going to be to diagram it. So that's what I have here. So the values are in there that we're given, and I have the 2 values listed that we're looking for. Now, for the next step, we're going to go ahead and create a little chart, our delta x or vx or t, and then the other side is delta y, VIY, VFY, A, and t. Notice t is on both sides, and that's because t is a crossover variable. The amount of time it takes to fall is the same amount of time it takes to travel horizontally. So whatever you solve for t in either column, you can put that t in both. Now to figure out the distance away that it lands or the height of the table itself, you can go in either order to solve that. In the case of the horizontal distance, you want to use the delta x equation. If you're looking for vertical, it's delta y. 2 answers you should get are 1.2 and negative 0.78. Now the answers at the end, though, is being the distance from the table. That's going to be our delta x, or 1.2 meters. And the height of the table is going to be 0.78 meters. We generally don't refer to heights in terms of negative values, so we're just going to write it in as positive. Now for number 2, this is probably the most complicated problem of the bunch. You have an object that is being shot from the top of a cliff that's 20 meters tall, and it lands 36 meters away. Diagram's there, the chart is there, filled in red what we're given. Notice that the 20 is negative 20, that's because it is ending up 20 meters lower than where it started. Remember, you have to go by the perspective of the object in the situation. So the first part, if we don't know time, we want to find that first. So that's the first thing we do here, the delta y equation to figure out our time, we get the 2.02. Remember, since VIY is 0, since it's launched horizontally, that means that first t is going to drop out. You don't have to worry about doing the quadratic formula to figure out for time. The next bit, we're looking for the total speed that it was launched at. Since it's launched horizontally and that VIY is 0, that means the total speed is just Vx. So we go to the delta x equation to figure out what Vx is. Now for the second part, we're looking for the total velocity, or the total speed, and the angle of impact. So to figure that out, we need to know both components of the velocity, because that Vx is going to remain constant throughout the entire motion at 17.8 at the beginning, 17.8 in the middle, and at the end. Now at the very end, though, and the entire way down through, it is going to be accelerating in the vertical direction, so Vy is going to be changing. So at the very end, we can't say Vfy is 0. Vfy is going to have some kind of value to it. We've got to figure out what it is. Now to figure that out, we're going to go to the Vfy equals Viy plus At equation. Viy is 0. We just solve for time. We can figure out that negative 34.7 meters per second is the final y velocity. You could also use the Vfy squared equals Viy squared plus 2a delta y to figure that out. And you may want to do that if you're not comfortable with your answer for time. If you're not sure that's right, you can go to that other equation. That way you're only utilizing variables that are given values and not something that you had to solve for. So now that you have Vxy, you have Vfy, you can figure out what the total speed is. The x and the y create a triangle with your total velocity. Now that is a right triangle. You can go ahead and use the Pythagorean theorem to figure out what Vt is. That comes out to 39 meters per second. So that is our total speed on impact. But we need a direction to it as well, because it asks for what is the angle of impact. And we go to a trig function. In this case, I'm going to use inverse tangent of Vy over Vx. So I'm going to plug in 34.47 and 17.8 and get an angle there of basically 62.7 degrees. And you could use cosine or you could use sine, because at that point in time you have all 3 sides of your triangle. You can use any of the functions you want. Just make sure you're using the right sides when you're plugging those values in. Now for our final answers for number 2, initial speed 17.8 and the final speed and angle of impact 39 and 62.7. So for question number 3, we have an object rolling off a table that's 1 meter tall. It's traveling at 2 meters per second horizontally when it leaves the table. You need to figure out how far away is it going to land. So we'll start off with making a little diagram, then the chart, filling in the values, and since we don't know it, we solve for time first. Use the delta y equation and work that through to get a time of 0.44 seconds. After that, we can jump to the delta x equation with the Vx of 2, the time we just solved for, to get a delta x of 0.88 meters. Final answer being that the object lands 0.88 meters from where the end of the table was. Number 4, this is the cargo plane problem. So it's traveling at 100 meters per second, and the item is pushed out. The altitude is 2,000 meters. how far ahead of the drop zone would you have to release it? So since the plane is traveling at 100 meters per second and the object is being pushed out, we're going to say that our initial velocity is 100 meters per second for the object as well. So Vx plugs in there, the delta y negative 2000, A, V at y 0, plug those values into your chart. And again, time is the thing we don't know, solve for that first. Using our delta y equation, we get a total time of 20.2 seconds. Plug it into delta x, and then again you get a distance of 2,020 meters that you would have to drop it before the launch zone in order for it to land where you want it to. So that's it for the 4 problems I had to do yesterday. Check again tomorrow for the next 3.